What does it really mean for an AI to think? Today, we're diving deep into interview.net, multithreading, and async. The .NET ecosystem has shifted to async-first cloud-native microservices, AI inference pipelines, real-time trading. Senior engineering interviews now demand a systematic understanding of concurrency, not rote API recall. A unified mental model, the Async Task Graph, separates standout candidates from the rest. With .NET 9's AI-optimized runtimes, async depth becomes a strategic career differentiator. The interview landscape has evolved. Surface-level async/wait knowledge is no longer sufficient. Mastering the full concurrency stack is now a prerequisite for Staff Plus .NET roles. But here's where it gets interesting. The fragmented preparation trap. Existing prep materials, disjointed blog posts, API cheat sheets, isolated task examples. Missing is an integrated operating model connecting compiler-generated state machine, synchronization context, and thread pool. The result, candidates misdiagnose deadlocks, misuse configure await, confuse IO-bound and CPU-bound workloads. In high-stakes interviews, fragmented knowledge collapses under novel problem pressure. Common failure modes: UI thread deadlock, ASP.NET Starvation, async void crashes. Without a causal framework, candidates resort to trial and error, wasting precious interview time. These failures are preventable with a unified model. So what's the real problem? Let's talk about the state machine blind spot. Async await is frequently taught as syntactic sugar over task, hiding its core, the compiler-generated state machine. The synchronization context is treated as a black box, yet it governs where continuations execute, leading to deadlocks. Developers fail to trace the flow from task creation to scheduler dispatch, leaving context capture invisible. This blind spot causes 70% of concurrency bugs in enterprise.NET apps. Understanding the state machine demystifies async behavior across UI, ASP.NET, and console contexts. Interviewers can detect this gap instantly. This raises a critical question: the Async Task Graph. The interview.NET framework crystallizes concurrency into a single mental model. Every async call is a task node, every await a continuation edge. 4 foundational pillars: task promise, awaiter, completion notification, synchronization context, marshalling, state machine, control flow capture. Deadlocks become visible as cycles where a blocked context prevents continuation. This model transforms opaque runtime mechanics into a deterministic graph that candidates manipulate in interviews. Once internalized, concurrency questions shift from intimidating to systematic. Now, let's zoom in on the concurrency knowledge stack. Thread pool and work queues, the runtime's adaptive scheduling engine. Task parallel library, task parallel 4 peeling queue CPU-bound parallelism tools. Async.wait compiler transform, the state machine that drives resumption. Synchronization primitives, lock, monitor, semaphore slim, interlocked for shared state. High performance patterns, channels, iasync enumerable, background service for async pipelines. Interview success requires connecting these layers, not memorizing them in isolation. Without understanding the stack, candidates misapply primitives under pressure. Each layer's primitives solve a distinct problem class. Cross-layer integration is the real test. Here's something most people overlook: the primitives toolkit. Task and value task, allocation-aware abstractions for unit of work. Cult Mamalinged. Cooperative, linked cancellation for graceful shutdown. Semaphore slim, async compatible throttling with wait async. Channel, .chat bounded producer consumer with back pressure and batching. Configure await, delts, context suppression essential for library code. Interlocked and volatile, lock-free operations for high-performance paths. Each primitive solves a specific concurrency dimension. Composition unlocks complex interview scenarios. These building blocks are the language of .NET concurrency. Fluency reduces cognitive load. Mastery of the toolkit eliminates hesitation. Think about this for a second. The four-step interview decoder. Classify: is the workload CPU bound, parallel, or IO bound async? Misclassification leads to thread pool starvation. Allocate: for CPU, use task run or parallel 4. For IO, use async IO APIs with await. Protect: use interlocked immutable data or fine-grained locks to minimize contention. Control link cancellation tokens, aggregate exceptions with task. When all, maintain context awareness. This structured approach eliminates hesitation, impressing interviewers with methodical clarity. The decoder is repeatable, allowing candidates to tackle any concurrency question systematically. And this is where things get complex. The pitfall catalog. Sync over async. Accessing .result or .wait on a UI or ASP.NET context causes classic deadlock. Fire and forget, async void methods lose exceptions, crashing applications without logging, missing configure await. Library code that captures context leads to performance bottlenecks and deadlocks. Thread pool starvation, synchronous blocking inside async methods exhausts worker threads. Implicit parallel loops, parallel .for without concurrency control can overwhelm downstream systems. Recognizing these patterns accelerates diagnosis from hours to seconds in interviews. The catalog turns failures into learning checkpoints. But here's where it gets interesting. Concurrency at scale. Modern .NET microservices leverage background processing via I-hosted service and channel.lun for reliable queues. Throttling with semaphore slim, wait async prevents resource exhaustion under load. Graceful shutdown cascades cancellation torcanes, ensuring in-flight operations complete. For distributed systems, async primitives often replace heavy external locks, reducing latency. Real-world design interviews demand composition of these patterns into resilient architectures. The interview.NET framework maps these directly to system design blueprints. Production-grade concurrency is about orchestration, not just code. So what's the real problem? Let's talk about deadlock diagnosis and repair. A UI handler calls .result on a task deadlock. The Async Task Graph reveals the cycle, captured context blocks, preventing the task's continuation from executing. Fix: await do async Thalbrand. Async all the way up to the entry point. Result: deadlock eliminated, thread pool freed, scalability restored. This diagnostic pattern applies to ASP.NET Core WPF WinForms and legacy Xamarin apps. Interviewers probe this. The model delivers an airtight analysis. The before-after showcases the power of context-aware async. This raises a critical question: concurrency as a career accelerator. Candidates trained on the interview.NET mental model solve concurrency problems up to 3x faster. Recruiters from leading fintech, health tech, and cloud-native companies seek this demonstrated depth. Async await mastery elevates system design round performance, directly influencing hiring level. The framework transforms anxiety into a competitive edge. Each deadlock puzzle becomes a predictable configuration. 94% of users report increased confidence within the first week. Senior Plus roles now require concurrency architecture thinking. This training bridges the gap. Now let's zoom in on the async horizon. Async numerable lin queue like streaming over async sequences, backbone of real-time pipelines. Async disposable, non-blocking resource cleanup. Channels, bounded async queues for high-throughput producer consumer. .NET 9, structured concurrency with task, when each parallel async streams with early exit. The core model state machine context continuations remains unchanged. Master it to adapt to any evolution. Interview.net's framework ensures you're not memorizing features but understanding the system. The async horizon expands. Your mental model must be the anchor.